Welcome everyone. This is the Legacy School Science lesson for Physics Year 8, Chapter 14, Pressure, Part 2. For this, you will need your Science Checkpoint Book 3, pages 183 to 188. We've talked about pressure in solids and pressure in liquids. Now we're going to discuss pressure in gases. Pressure of the atmosphere. The atmosphere is a mixture of gases. The molecules from which the gases are made move around but are pulled down by the force of gravity exerted on them by the Earth. The atmosphere forms a layer of gases over the surface of the Earth that is about 1,000 kilometers high. This creates a pressure of about 100,000 Newton per meter square, equivalent to a mass of 10 tons on 1 meter square. Although this gets less as you go up through the atmosphere, you do not feel the weight of this layer of air above you pushing down because the pressure it exerts acts in all directions, as it does in liquid. Thus, the air around you is pushing in all directions on all parts of your body. You are not squished because the pressure of the blood flowing through your circulatory system is strong enough to balance atmospheric pressure. The atmosphere does not crush ordinary objects around us. For example, the pressure of the air pushing down on a tabletop is balanced by the pressure of the air underneath the table pushing upwards on the tabletop, because the particles of air or the particles of gases move in all directions. Ear popping. The middle part of the ear in figure 14.4 is normally filled with air at the same pressure as the air outside the body. The air pressure can adjust because when you swallow, the eustachian tube in your throat opens and air freely enters or leaves the middle ear. For example, if the air pressure is greater outside the body and in the mouth, when you swallow, more air will enter the middle ear to raise the air pressure there. If you travel in a car that quickly climbs a steep hill, your ears sometimes pop. This is because you are raising rapidly into the atmosphere where pressure is lower. The popping sensation is caused by the air pressure being lower in the throat and outside the body than in the middle ear. The difference in pressure causes the eardrum to push outwards. When you swallow, the air pressure in your middle ear reaches the same pressure as the air in your throat and outside, and the eardrum moves quickly back or pops into place. This is figure 14.14. It shows the ear and the throat. Here we have the middle ear, we have the throat here, and this is the eustachian tube. It connects the middle ear with the throat. The pressure inside the middle ear has to be the same as the pressure outside and the pressure in your throat. What happens when you're traveling up a steep hill fast, because the air pressure outside will become less and less as you go up. Since the higher you go, the colder it is, so the particles will start to move slower, decreasing the pressure. This will cause the pressure inside the middle ear to become higher than the pressure that is outside, which will cause the eardrum to bend outwards because all of the particles of air inside pushing out on the eardrum. When you swallow, you open up the eustachian tube and you allow all of these gases to be drawn down into the throat. What happens is now, instead of having the eardrum being pushed outward by the increased pressure, when this pressure is no longer there, the eardrum is going to pop back into place. And this is the popping sound you hear. How a sucker sticks. When an arrow with a sucker on the end hits a target, the arrow stays in place due to air pressure. As the elastic sucker hits the flat surface, it deforms and pushes out some of the air from beneath the cup. The pressure of the remaining air in the cup is less than that of the air pressure outside the cup. The higher pressure of the air outside holds the cup and the sucker in place. Okay. This is for the arrows that sticks. So what happens is, when you shoot the arrow, it flies through the air and it grabs some of the air particles with it. So some of it will be trapped inside the arrow or inside the dome of the arrow. And these air particles are going to try to push outwards. But since there are less than the pressure that is outside, the pressure outside will be pushing it towards the wall. And this is what keeps it sticking to the wall. Now the pressure outside is more than the pressure that is inside. The pressure that is pushing against the wall is higher than the pressure that is pushing away from the wall. Crushing a can. The strength of the air pressure in the atmosphere can be demonstrated by taking the air out of a can. This can be done in two ways, using steam or using a vacuum pump. Using steam, the can has a small quantity of water poured into it and is heated from below. As the water turns to steam, it rises and pushes the air out of the top of the can. If the heat source is removed and the top of the can immediately closed, the remaining steam and water vapor in the can will condense, leaving only a small quantity of air in the can. This air has a much lower pressure than the air pressure outside and the can and the higher outside the can. And the higher pressure crushes the can. Using a vacuum pump can reduce the pressure in containers. If one is used to remove air from a can, the can collapses due to the greater pressure of air on the outside. A scientific showman. Otto von Guericke was the mayor of Magdeburg in Germany for 35 years. He was also interested in science. He was keen to discover if a vacuum could really exist and made an air pump to test his idea. He used his pump to draw air out of a variety of vessels. When he tried barrels, he found they collapsed. He eventually found that hollow copper hemispheres joined together to make a globe or much stronger. Aristotle had believed that if a vacuum could exist, then sound would not be able to pass through it. When von Guericke put a bell in one of his vessels and removed the air, he discovered that a ringing bell could not be heard. Von Guericke greatly enjoyed demonstrating his discoveries to a large number of people, and in one demonstration had 2 teams of 8 horses pull on the evacuated hemispheres without separating them. This spectacular demonstration helped people to realize the strength of the air pressure pushing on the hemispheres. Aerosols. An aerosol spray can contains a gas that is at higher pressure than air pressure. It is held in the can by a valve in the nozzle. When the nozzle is pressed down, a spring is squashed and the nozzle opening enters the inside of the can, effectively opening the valve. The higher pressure of the gas in the can pushes on the liquid in the can and it rushes up the tube and through the jet, where it forms a fine spray of liquid droplets, an aerosol. When the nozzle is released, the spring is no longer squished and it pushes the nozzle upwards. This removes the nozzle opening from inside the can, effectively closing the valve and stop the flow of spray. Aerosol cans used to contain a gas made of chlorofluorocarbons. These chemicals are now known to damage the ozone layer. In many countries, they have now been replaced with gases such as gases produced at oil refineries that do not damage the ozone layer. Okay. These cut pictures are from this part of the can. As you can see, we have the spring, which is here represented by the 2 black lines, and when the nozzle is pressed down, this allows the opening of the valve to enter inside the can. So now there is an escape room. So all of the gas that was inside the can, causing all this pressure, is going to be pushing down on the liquid. When it pushes down the liquid will travel up the tube and come out as an aerosol. When the nozzle is no longer under pressure, this spring will be released and then it will effectively push up the valve, putting it outside of the can and then stopping the flow. A hovercraft. A hovercraft uses the pressure of air to raise it from the ground. It does this by drawing air from above with powerful fans. There is a skirt around the edge of the hovercraft which prevent the air from escaping quickly, and the air pressure beneath the hovercraft increases. The upward pressure of the air trapped beneath the hovercraft lifts the hovercraft off the ground. The fans continue to spin to replace air that is lost from the edges of the skirt. The cushion of air beneath the hovercraft reduces friction between it and the ground. The cushion of air is also maintained when the hovercraft moves over water. The forward and backward thrust on the hovercraft is provided by propellers in the air above the hovercraft. So this is an example of a hovercraft. What happens is it has huge fans, and these fans, they draw in air. They bring air to underneath it. When air becomes on the bottom, what is it going to do? Because air particles move in all directions, they're going to start to hit in all directions, hitting upwards, hitting sidewards, and hitting downwards. As it hits upward, when there's more air particles hitting upward, what happens is it becomes higher pressure, causing the hovercraft to raise. On the side, it has flexible skirts. These are there to stop the flow of air particles to escape. If they try to escape, then these fans will push them and keep them underneath the hovercraft to keep the pressure higher for the hovercraft to raise. As the fans continue on to bring more air particles, which are also going to come back down and then raise the hovercraft higher. This is the end of this chapter. I'll see you again soon.